might try this every week we're in here, and just come back and play a little bit more, so that by the end of the semester I'm playing. It's probably not going to happen though. Today's topic. I guess it's probably worth giving you a bit of context about this, a bit of the course that I'm teaching on. In this element, I am going to be looking at some of the like the technical aspects of the web architecture, like the practical bits of it, and like learning how to use it, or teaching you, or helping you guys learn how to use it. I won't teach you every bit step by step all the time. I will guide you towards resources that will do that. Primarily, I'll give you an introduction to the technical bit that we're going to be looking at for that particular week. Some justification for why it got to the state that it's in, and then like a very brief guide to how it works. But it's your responsibility to go and learn that in more depth. I will support that a little bit though, so because we've got two sessions. We've got the Thursday session, which will typically be sort of theoretical. It will be that sort of that brief introduction, that explanation about the technology and why it's the way it is, and sort of the key points around it. On the Friday, we'll then look at that in a practical sense. So the Friday session will typically be made up of a bit where I demonstrate it working in practice, and a bit where, actually I think 3 bits. It's difficult to explain because tomorrow we won't do all the bits. Tomorrow I'll just demonstrate how HTML and XML works in practice. Like I'll go through some examples and we'll see it working. And then I'll set some tasks to do over the next week. Group tasks, they are based back on the general sense that they're not set. You won't get targeted tasks. What I really want you to do is because they're important for you learning how these things work. And I want you to work in groups so you're not, so you don't get stuck, so you've got each other to work with. Ideas off each other. If you're stuck. So yes, once we've done that, I'll get you to go away, do that group activity, and then send the results of that back in. So submit the results of that back in through the universities, or through EGS's handling mechanism. And then the following week, I will then take some examples from that and point out the key things that people did right and wrong, what we can learn from the work that you've done over that group activity. So, and then that ongoing format will continue. So we'll feedback on the last week's activity, go through some practical examples of the current week's topic, and then set the activity for the next week. That's going to be the structure of these sort of Thursday, Fridays for the next 4 or 5 weeks. And then we set the coursework that is related to this area, which is around a topic called REST. But it does bring in all the elements that we talk about in the which is why you need to keep up with the practice of those parts. Are there any questions about that? You'll see it working as we get through the weeks. It's not too complicated. So today, the first topic we're going to talk about is HTML. HTML is a key part of the web architecture in terms of representation. So the web architecture is made up of identification, so URI, referring to a resource, representation, a way of the format standards for getting across data and information to people, and interaction, which is how you communicate with the rest of the web. And HTML, XML, and analytic topics, variations that we're going to talk about today, are how we do that representation for the web. Now, HTML, who has written HTML before? Not everyone though, so we're going to talk about it. So HTML is about representing documents. It is a format for marking up documents and explaining what the different parts of that document are. So in this diagram, which I hope links to the code example on the next page, we have what it looks like when a web browser interprets your HTML. So this isn't HTML. This is a rendered version of an HTML document. But you'll see there are various aspects to this. There is something that looks a bit like a title. There is something that looks like a list. There are things that are paragraphs. And if you just had the text in that document, your computer wouldn't know what any of those parts mean. It wouldn't know that those are different things unless you tell it. So we need a language for describing those differences in the document, and HTML is one of a multitude of different formats that allow us to do this, but it's the one that's standardized for use on the web. It's the one that your web browsers are designed primarily to interpret and render. And whilst there's some other bits that that aren't really visible in that original example, we see things like the section that was looked like a heading have these tags that are called H1 tags. The bits that were a list have OL and LI tags, and the bits that were paragraphs have these tags around them. So a tag is that thing with the angle brackets next to a letter or a word. But we'll talk about how they fit into everything later. In terms of what each one means, that's one of those things that you want to go away and look up and follow tutorials to get more information. I will put some links at the end of this to where, when we go through tutorials of like what does each tag mean, what does it all refer to. So there's a bit of history about where this came from, and sort of how it's evolved to the state it is today. And through that we're going to explore XML as well, and in XML we're going to look at what structured documents, like these sorts of documents, and how they fit together. So, HTML was a language designed at the time the web was forming, so in the late 80s, early 90s, as a way of representing documents that were hypertext. You've only seen Les so far, haven't you, on Monday? Who can tell me what hypertext is? Can anyone define what hypertext is? Keyword, yeah, link. So a hypertext is any document where you can link between either bits within the document or into other documents. And the web is a hypertext, and the web needed a documentation format that supported hypertext, that supported linking. But rather than reinventing the wheel entirely, this was based on a language called SGML. Who's heard of SGML? See, even fewer. But it is it's the ancestor, the grandparent of HTML and XML as well. So SGML is mega complicated. Both of these are simplifications of SGML. HTML is a specialization of SGML in that it's purely for HTML documents. And the aspects of that, the things that it supported, were things that would go into a document. So in the example we saw before, we had headings, we had paragraphs, and we also had access to things like being able to emphasize things in italics or bolding. But the important thing it was doing was marking up semantics of a document. So what things go into a document, HTML enabled you to refer to those. The issue was that over time, as web browsers began to sort of jazz on this initial riff and look at, well, we've got these very basic document semantics, we've got these very basic things that we can refer to in the document. What else could we do? What else could we enable? Certain browsers started adding support for other tags that weren't necessarily part of the standard, but the people who were developing web pages started using. And this began to sort of cross the boundary between just defining which bits of the document were which parts of the document, so structural things and relating to lists and whether something was emphasized, started becoming a way of also explaining how to display this document. So how do we centralize a bit of text? Well, why don't we add a tag that supports making it centralized? What about if we want the text to blink? What if we want it to flash? Well, let's have a tag that does that. This both bloated and confused what the point of an HTML document was. We've lost track of the purpose of it, which was to mark up a document. We've now confused the issue of what the presentation is as well. So in the late 90s, early 2000s, there was a move to separate those two, to abstract the document layout and the document structure from the style and the presentation of that document. And we will see more about that and like the technology behind that in 2 weeks' time when we speak about something called CSS, Cascading Style Sheets. But let's now imagine a situation where we move back to just having tags in our HTML that are structural, that define the elements of our document, and we have some other format, CSS, that we'll talk about what that actually looks like later, that explains how to display this. So our heading should be large, bold and red. That is a separate piece of information to the tag itself. So rather than having a tag that's called like large, red, bold heading, we just have the heading tag and the stylistic part is separate. And this sort of leads us to almost a debate of, well, actually, once we do that, does it even really matter what the tags are called? Does the structure of the document become important anymore? We become more interested in what the style is. And that argument leads to, well, actually, could we just define all the structural elements, all the tags ourselves, and use that to refer to data that's in the document, as opposed to it being document structure. And that approach, which we didn't see implemented in HTML, but was being discussed as a route for representing this information, led us to something called XML. So how about given we've got something to represent the style of our document, well, how about we refer to our documents purely through the data we're trying to represent within this? And that led us to XML. Now XML is another variant of SGML. SGML enables you to represent just about anything. HTML was a specialization that allows you to represent hypertext documents. So once people have become competent in HTML and we were looking to represent other forms of data on the web, people went, well, should we go back to SGML? SGML is an option here. But SGML was so complex and potentially had features that people didn't need anymore. There was a move to create a new language that was like a lighter version of HTML, and from that was born XML. Now, XML looks a little bit like HTML in that it has tags that have angle brackets around them. But you'll notice that the tags that we use are not to do with documentation. They're to do with the data that's being stored within that, within this file. So in this example, if we're viewing the raw XML example, we're looking at books and a book list, and within the books we might have items that have a title, an author, and a price, and how many we've got. So this is evidently a sort of database for a library or for a bookshop. Now, because it's structured, we can view it in other places. So if we view that in the browser will interpret that to some level and render it so that we have some syntax highlighting on that to enable us to sort of see the key parts separately. But let's go through the key components of an XML, of the XML structure. So the two things that are really, really useful to us that we'll spend a bit of time on are XML elements and XML attributes, entities, declarations, processing, instructions, DPDs. We won't speak about too much, but I will mention. But let's go through each of those. So, the element are those tags. So when we talk about XML elements, we mean the piece of data between a pair of tags. And these form a hierarchy. So, do we have an example there? Yeah. Some of these tags, some of the groups of tags are within the other tags. So it forms a hierarchy because of that. So in this example, so when I'm saying inside something, I mean between the opening and closing tag of the relevant element. So we have a book opening element here, and the equivalent booked closing element is down here. A closing element has a slash at the start of the name. So the opening one is just the name, the closing one is slash the name within the angle brackets. And now between those, we've got another set of elements. So we've got item, and within item, so between the item opening and the item closing, we have title, author, price. But note those are next to each other rather than each of those is next to each other rather than beside each other. Yeah, please.
The cat equals S on the item tag. What's that representing?
In this particular data set, or in general?
Well, or in general, yeah.
Okay. So this element, so this part, the cat equals S is an attribute. We'll speak about that in the about next. That is a form of metadata to do with that element. So it's an extra piece of information that is about that element itself, as opposed to it being something within that element. There is a fine line, or there is a fine line sometimes between whether you choose to make something an attribute or an element. Maybe we'll discuss that a little bit after we've looked at what both of those are. Yes, so the things with tags are elements, and because you can put elements within other elements, because you can put them between the open and close tag of another one, we automatically get a hierarchical structure from that. So we have chapters and paragraphs within chapters, chapters within books, books within bookshops and book lists, and so on. And whilst in your document, in the written textual document, you might see that running linearly top to bottom. You can represent that as a tree diagram, as a graph. So you can conceptually separate this out to being a book with chapter elements within it, and within the chapter elements there are paragraph elements, and so on. And it's useful to be aware of this. It's useful to be aware that your document is structured in that way, because it allows you to talk about those various elements in relation to each other. And you'll hear this language a lot when you're developing in the web, because you'll need to refer to various elements relative to each other. So when an element is inside another one, it is the child of that element, and therefore the outside element of that in that relationship is the parent. So in this example, the chapter element is a child of the parent of the book element, and the book element is the parent of the chapter. And so on, this follows, so a paragraph is a child of chapter, and so on. You might also hear people talking about sibling elements, so the paragraphs within a chapter of siblings, and whilst that's clear in a tree diagram, remember it's not always that obvious when you're looking at it like this. You have to remember that look for the open and close tags of the element you're looking at to realise that these things are siblings within each other, or next within that parent. And you might also hear, like, those are the two key terms that people will refer to when they're talking about elements within this hierarchy. But you might also hear about people talking of ancestors and descendants which is similar to the parent-child relationship, but just deeper within the tree. You will also hear this hierarchical structure when spoken about in a web browser and referred to in sort of HTML context as the DOM, the Document Object Model. So if you ever hear the word DOM in relation to web architecture and HTML, it means the hierarchical structure, or a computer representation of that hierarchical structure for the document that you're currently using.
Sorry, document
object model. Yes, please.
You know when you said ancestral descendants, so I've not heard that before. So descendants, is that the extreme child of the parent? Not like the third down the line.
No, it's just anywhere.
So don't exactly the same extreme parent child.
Yeah, just further down. So a child is a direct descendant, so you can only call it a child if it's one level in. If it's any further.
Oh, any further. So just more than one layer of abstraction.
You got it. Okay, so that is the elements and the broader tags that provide you the hierarchical structure. And that is the key way to represent things in XML and HTML as well, all the HTML variants. The other very useful aspect of the XML standard are attributes. So attributes are that bit that we had the question about where we have an extra piece of information within the elements tag. So in the example we had before, the only example of an attribute within this is this one here, category equals S. And within this example, anyone got a guess what that is referring to?
Category.
Oh, sorry. Yeah, I think it's category, but what about an item would be category S?
What's the alphabet, isn't it? It's just testing the alphabet.
Same. So like location, or maybe it's something. It might be topic. It might be science.
That's the first letter.
So the first letter of what?
Well, it's just
It's just given any category. Yeah, possibly. It's a rather specialist example of this, but that is our only example of an attribute. Let's see if we've got any better ones here. Yeah, so it's probably a better example within the structure of a book and a paragraph. It makes sense, at least within this example, to have a paragraph as a child of a chapter. Like the paragraph is an extra set of data that fits within the structure of a chapter. Which number the chapter is, so the order it is within the document, isn't necessarily an aspect, like a sub-part of that chapter. It's more general data about the chapter. It is a description, or it's metadata about the chapter, rather than it being a component of the chapter. Does that make sort of, do you buy that?
Mm-hmm.
Like, a paragraph is definitely a thing within a chapter, but which number the chapter is information about the chapter. You might not even necessarily display it. It might just be information that's stored within the representation that isn't actually displayed. So that's what attributes are for. So attributes allow us to label our elements in some way. You can have multiple attributes, you can have no attributes. There are no real rules at the level of XML standard. But we will talk about the way that you can constrain that, the way you can define that. So you can go away and write XML to represent absolutely anything you wanted in any structure that you wanted, using any tags that you want today. You could sit down at your computer, you could write something that is valid XML as long as you get the tags and stuff in the right order. But if you want other people to write that, or you want other people to understand that, you need a way of defining what it looks like. And the way you do that in XML is you define something called a DTD. A DTD is, confusingly, another XML document, but an XML document that defines the format, the expected format of your specialist XML document. So if your specialist XML document had books and chapters and paragraphs, you could define a DTD that says every one of these, every book document I create is definitely going to have a book. It's definitely going to have 0 or more, 1 or more chapters, and each chapter will have 1 or more paragraphs. And all the chapters have to have an attribute that is called number, and it will contain a digit of some sort. And that means you can test whether other people have created their XML correctly, and it also means you can interpret their XML because you know what's supposed to be expected. And yeah, it provides a grammar of sorts for describing what is going on in the document.
There isn't a standard, it's saying that XML isn't a standard language.
It's a standard language, if that makes sense. It's a standard language for defining your own document language.
So it's like a grammar, it's like a grammar of my own language that I made up, so
Yeah.
someone else can read it. Why don't we just have a standard language? Is that not what XML is?
XML is a language that lets you create any of those standard languages. What would the standard language be for, though? So, very good question, but what?
So what, do you know what I mean, so I'm an applied linguist, so I go language, do you know what I mean, because it is language, so what, obviously, if we're going to agree that we're going to speak in English, we have to agree that the word "and" is a coordinator that coordinates to phrases, do you know what I mean, so if we don't agree that and we don't know, obviously I'll talk to you and you'll go, yeah?
Absolutely.
So I'm just asking why isn't XML fixed? Can you make it up and then you can make another document up to tell everybody else what you made up? Is that what you're saying?
Yes.
Right.
Yeah. But it's because of different domains. So each time you have a different domain, you'll have a different XML to represent data within that domain. So rather than someone having to prescribe a way of describing every possible piece of data ever, it's left open enough that you can do that on a product by product or domain by domain basis. Does that make sense? So rather than having a computer scientist decide how to represent like all of botany, XML is an open enough and extensible enough language that botanists could decide how to describe the data that they need to talk about.
Make your own language within make your own language within XML using the DTD.
Well, the structure and this is what you can make up like your stuff. You can match and mix.
Sort of. Yeah, you can mix and match existing XML, or you can create your own.
Using like the basis.
Well,
No, I was just trying to get my mental model has got holes in it too. So if I write an XML, I can make up wherever I like to determine like elements in my thing.
Or whatever you want to represent.
What's it? But then if anybody else wants to read my page, I need to have some dictionary reference. No,
you don't
work
have
out what the
to,
DTD does.
Yeah, it's a definition. It's effectively a definition of
So it's like a dictionary.
It's a bit like a dictionary.
Right.
Yes, good example. It's a bit like a dictionary in terms of human readable language.
Yeah.
It's a dictionary for the computer to understand what those, or a human to understand that.
Yeah.
It's meant to be in your language.
Right.
Okay, so let's go through a little bit of, so that was sort of what the structure looks like in terms of, or what the hierarchy looks like diagrammatically, but let's briefly look at the syntax for these. Oh, this is terrible. Sorry. So foo is like a key, it's a word used in computer science to just mean anything. It's like blah or duh. It's just a space filler. So when we're creating tags elements, then we use angle brackets around the tag part. So left angle bracket, the name of the tag, right angle bracket. Then anything that follows that is the child, is the contents of that tag, until the point where we reach another left angle tag bracket, a forward slash, that keyword again, the tag name, and a right angle tag. Sometimes you have tags that are that have no data. So if we didn't have this contents of foo element bit of text, we can either represent it as the open and close tag, but you will also see a lot of people using the shorthand, which is open bracket tag forward slash close tag. So that's a shorthand for this. So if you have no information to go between the open and close tag, you still need the tag there to represent what the element is in the document. That's shorthand. Names are case sensitive, so uppercase, lowercase does make a difference in XML. So be aware of that. If you're having errors and you're not sure why, check the case sensitive sensitivity. What can go in that element? So the element contents might just be data, so it might just be text or numbers that represent the content of that element, but it might be a mixture of that and other elements. So we spoke about the hierarchical structure of that document. It might have a mixture of both text data and elements, more elements, child elements, or it might have elements only. Next thing about XML syntax. There are some reserved characters that if you try to use them as part of the content, the data within your elements, you will get an error. So because angle brackets, left angle bracket, right angle bracket, are a key part of a machine determining when you're talking about a particular element, like when you're starting an element, you can't use it as data because the machine needs a way of determining when you're talking about a tag, and it does that by looking for the angle brackets. So using an angle bracket for data can be problematic for the bit of software that's trying to read it. Because of that, we have something called entities, which are a way of using or displaying that character, but through a special name. So, for example, because the left angle bracket is a special character within XML, if you want to use it as data, you have to write ampersand LT semicolon. That's how you get access to that character. So, in the example above, we've replaced the left angle bracket in our bit of programming code with ampersand LT semicolon. The same for right angle bracket, and because if you notice that this ampersand LT, ampersand is now a special character for telling the machine that this is something special and it needs to be replaced with this. We then have to have a code for referring to ampersand as well, if we want to use those effects as well, and semicolons. In fact, XML provides a way of defining your own ones of these. So if you wanted to create sort of named entities that are replaced by a particular character or set of characters, there is syntax for doing that. It's called entities. Okay, so attributes. The other key part of the syntax here. These occur just within the opening tag. So when you open a tag like in all these other examples. All these other examples have no attributes. If you look in the opening tag, there's no other information in there. If we want to create an attribute, if we want to create that additional metadata about our element, then within the angle brackets of that tag, and after the name of the tag, so the name has to be the first thing in there, then we put a pair of pieces of information, and that is the name of the tag, followed by an equal sign, and then the value that it takes. And typically that value will be in speech marks, unless it's a number. So if it's textual, then it will be within speech marks. If it's not, if it's a number, then it can be unsigned. Yes, please.
I wanted to know that in HTML, attributes like ID are used in order to address that tag to be used for CSS styling or anything. However, on XML, when you define such attributes like security here, how would you tell the computer or your program, XML, to use it in what way? To use the attribute of security in what way? How would you tell that?
That's a good question. So the question there was, once we've created our own custom language to define a document, and it has certain things like certain attributes within it, how do we tell a machine how to understand that? Now, part of it's down to that DTD, dictionary, which is a machine-readable way of describing what to expect in there. So that will define that the machine reading this should expect a security attribute. But what to do with it? Well, that's down to the software. It's entirely up to the person who writes that software, who programs that software, to do something with each of the bits of data within this XML. So typically, the definition of your language based on XML will be defined as part of the development of a piece of software. There are some cases where people will create data or create an XML format that is purely used to publish, but that is often with the aim or the alongside the explicit action of developing a piece of software that can interpret that. It's rare that people create data all the time that might not be used, but the aim of creating something that is a machine-readable format like this is that a piece of software will interpret it, and that will generally come with rules, normally as a separate standard documentation or something like that, explaining what to do with each of those attributes and elements.
Can you show those rules, like what format?
It will be a part of a computer program, is what I mean. So it's up to the software code within a computer program.
Well, can you show that software code, like an example of it?
In which language? There are dozens of programming languages.
Any, you choose.
I don't have any now, but I'll bring something along tomorrow.
Okay.
Is that fair? Oh well, I'll make concrete that rather abstract explanation. But yeah, I can probably simplify down an example piece of code to show that. I'll try. I've only got until tomorrow afternoon, but I'll do my best. Okay, yeah. So it's entirely down to the software that needs to interpret the software. Does that sort of answer your question? So the only reason a browser can interpret the ID tag is because the browser has been coded to understand what an ID tag means. And that's because as part of the definition of HTML and HTML5, they have the organizations, the standards bodies that decided that format, decided that ID would be the attribute that refers to like naming a particular tag.
And in order for the computer to understand what security means, you have to tell it. You have to program it yourself as well.
You have to program it, yeah. Okay, right, so there are also a whole bunch of predefined entities we spoke about, less than, greater than, but there's quite a few others, and there's ways of referring to anything in ASCII characters and Unicode characters within that same sort of syntax. But I briefly want to speak about HTML5 for the last couple of minutes of this lecture. So HTML5 is, it's odd, we had HTML, We had sort of HTML 1 and 2, and then there was a move, once XML had been created, to make HTML an XML-based language. This was called XHTML, and it served this small bit in the history of the web, where W3C, the standards body for the web, were like, we have to use HTML, it's really nice and structured, and everyone should use it, and it's brilliant. And people who were actually making web pages didn't really like how XHTML enforced certain structures and forced them to build their pages in a certain way. So, since then we've had the big names within the world of the web, so the big companies within the world of the web, people like the search engines like Google and Yahoo, the browser manufacturers like Apple and Microsoft and Google as well, who else? And Mozilla, sort of take over where they wanted HTML to go, and this developed into the standard for HTML5. So it has a lot of features now that benefit and suit those stakeholders. So it benefits the browsers, it suits what people want to put in browsers, it suits what search engines are looking for within a page. But on the whole, that's also allowed people to more richly define their documents on the web. So it has structures that, like, the search engines are looking for, that enable us to do sort of accessibility a lot better, so that screen readers can access this. Look at the overall structure of the page. No, this is quite worth pointing out. So before HTML5, there wasn't really a way of defining particular sections of your web page, particular sections of your document, and what they meant. And what people realised over time was that people were using these very, very generic tags, like div and span, which are just, they're so vanilla, they don't really have any semantics other than it is an element within your HTML page. The name doesn't define anything about what has to go in there or the content that's in there. But we were sort of evolving towards a common type of web page. There were lots of web pages that shared similar structures, and this structure was things like there would be some sort of heading at the top of the page that was introducing what the content was going to be and what the website was. There was some navigation to get you from the page that you're currently on into other sections of the website. And then often there would be some core content. There would be an article, and that would have sections in it on the sides. And often there was a footer describing the web page. And before HTML5, you had no way of properly defining in a standardized way what each of those sections were separate to each other. And HTML5 has added tags that allow you to do this. There are header tags and nav tags and section tags and what else have we got? Canvases and footers and so on. So now we have tags where we can define that something is a navigation to a web page by using the NAV tag. And this lets your browser potentially highlight the navigation. It allows so bits of software that will turn a web page into audio for someone who has sort of difficulty seeing the web page clearly. And also it's useful for useful for search engines for highlighting the various sections of a page that you might go to. I don't know if you've done a search on Google, sometimes it will list like some of the more popular subcategories within or some of the most popular pages to go to within that site. That's partly down to the fact that those sites can highlight which parts of navigation within their site, and Google can extract that and display that in the search results. Header and footer allows us to define certain parts of the content, and importantly that means you can then also highlight the bits of the article, which is kind of useful for being able to jump straight to the thing that you actually want. So in terms of accessibility and usability, rather than having to scroll through the headers and things like that, you might not be interested in if you just want the content of the page. You now have marked up into your document where the core content is, and you're able to mechanically illustrate that. So we've also added a bunch in terms of like multimedia through HTML5, so video and audio sources, and Canvas lets you do 2D graphics, and you can draw when you want onto the web page. So HTML5 has added a lot of sort of content that's relevant to the web today. HTML originally was defined for just being able to distribute reference documentation way back in the early 90s, and we've moved on from that. We needed a new spec, HTML5 for that. Right, that is the end of the content, but I just want to point out places that you can learn more about the nuts and bolts of this. We will do some examples tomorrow of what this looks like in practice. But to learn this properly, go away and have a look at some of the tutorials that are linked on EdShare. If you've not seen EdShare, it's where the slides are. Hang on a minute, guys. And on the page where the slides are, there's a bunch of resources at the bottom that are linked out to a playlist of videos teaching HTML, a tutorial, and a website for W3 Schools, which has tutorials about everything to do with the web. It's a very good one to do with HTML. So I recommend picking one of those and going to research a bit more depth into how to use HTML using that. You don't have to finish that by tomorrow, sometimes expecting you to finish it today, but it's there for the next week. Over the next week, you'll be use something to expand your learning. Okay, right, that's the end. You can all go. See you tomorrow.